Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows. Super, and the reason we have people from the Azure Resource Manager team is because we're here to talk today about an issue involving ARM, Azure Resource Manager. This impacted our China cloud. It started on the 5th of September, and it was about 13.5 hours in duration.
So with no further ado, I'd like to introduce our two speakers who are going to be talking us through this incident today. First up, we have Brendan Burns, our Corporate Vice President of Azure Cloud Native and Resource Management.
In addition to that, we have Mark Reiner, our Partner Group Software Engineering Manager, also in the Azure Resource Manager team. Brendan, if you don't mind, I'd like to start with you. In the PIR, we mentioned that most of the impact to this was in China North 3 region. But we understand that ARM is a global service, and there was also impact to other regions within our China cloud. Could you help us understand how does a global service, is it isolated? Was it only China 3? Was it more regions or not? Just can you help offer some clarity there?
Yeah, sure. There's actually two ways in which ARM has sort of broader impact, even when it has primarily impact in a single region, has broader impact. The first is this particular outage was around our batch jobs that do deployments. So when you create a VM, there's a background process that happens that creates all of the NICs and disks and all the pieces that make up a VM. That background job is actually shared between multiple regions, and we do this for resiliency. In case a region is having an issue with processing, we would share the deployment with a different region that would pick up those deployments. Unfortunately, in this particular case where we were having issues with the deployments in a particular region, that meant that there was some impact in other regions that were paired up, in the other region that was paired up with that China region. And then I think the other thing that's worth pointing out is that while ARM is regional, people deploy resources from around the world into that region. So, anyone who is trying to deploy resources into that specific region, no matter where they were coming from, would also have been impacted. So that kind of shows ARM is at that sort of crux between purely regional virtual machines and a global control plane that we provide to our users around the world.
That's great to understand the blast radius here. So there was kind of some impact to other regions in Azure and China, but most of the impact here for that China North 3 region. Mark, I'd love to turn to you. Could you help us to understand what this impact would have felt like for customers? I understand ARM wasn't actually down. It wasn't an ARM outage altogether. The post-incident review mentioned these long-running control plane operations. Could you help us to understand that a bit?
Sure, of course. That as ARM is deploying processing resource operations, that we need to track background state from that one. As Brendan was saying, that, hey, as part of there's multiple resources involved in, say, creating a virtual machine, you have the NIC, you have the disks, and at each step we need to track that, hey, is it done? Can we move on to the next one? And during the outage, our background worker processes were crashing, and so if the job wasn't picked up by a crashing worker, we might miss that it finished, and then it would be delayed from when we picked up and resumed that. And so individual operations would have still been processed, but ARM kind of noticing that background processing had completed would have been missed because our background workers were crashing.
Got it. That's helpful to understand. The key thing I wanted to pick up on there that you were saying is we might have missed that it's created, that it succeeded. So customers who requested a virtual machine, actually that request would have been successful. That VM would have deployed. They just might not have known about it. Might customers have retried and things like that?
Yeah, I think. Oh, go ahead, Mark.
Thanks. On retry would have that even if ARM didn't notice that the operation had finished, that VM would have still been created. Then ARM would have caught up later to record that, hey, that VM was indeed created.
Right. And I think at a customer experience level, someone might have experienced like the spinner in the portal kind of going into an infinite loop, waiting for the operation to complete, despite the fact that actually the virtual machine was there.
That's cool to know. So even if a customer's hitting retry on the same resource, it would have been created once, and that's kind of done. That's interesting.
Yeah, and I think one of the important concepts that we use in ARM is this idea of idempotency. which means that sort of no matter how many times you retry the same thing, as long as it is the same thing, the same virtual machine name, the same specification, you won't get 20 copies. You'll get one copy. That's the beauty of declarative infrastructure as code, where you say, this is what I want, and the system is responsible for making that into reality. No matter how many times you assert, this is what I want, we only do it once, as opposed to, if it was imperative and every time you asserted that, we tried to do it again, and you'd end up with 20 virtual machines that you needed to then clean up. That would be a pretty bad experience.
It is, and I do when I download my Excel files, I see 30 of them sometimes, each with parentheses of 1 all the way up to 30.
That's right. We don't do that. We don't do that.
It's pretty cool. Brendan, when we were speaking the PIR, we try very hard to avoid the term root cause, because we understand that complex systems, such as ARM, such as cloud tech, they fail in complex ways. But we did mention there was a latent bug, but it was only triggered during a certificate rotation. Could you help me understand the certificate rotation and how it triggered the bug?
Sure. So we were in the process of moving from a legacy system with manually managed certificates for encryption to a more modern system with automatically handled certificates for encryption, where those certificates were rotated automatically and that sort of thing. And so we were in this situation in China where we were transitioning where some things were encrypted using the legacy system and some things were encrypted using the more modern system. In order to work through that in our code, we actually would try both, right? You don't know per item which encryption certificate and library has been used. So you try both, and if one fails, you move on to the other one. Now, unfortunately, unbeknownst to us, the more modern encryption library that we were using, which was a dependency provided by another team within Microsoft, had a bug where if the format was totally different, which was true for the legacy provider, the format of the whole envelope of the encrypted data was different. Instead of just returning an error, which would be expected, it actually crashed. And so, unfortunately, when we were performing this migration from our legacy encryption to the more modern encryption, when the new library encountered something that was encrypted with the old legacy approach in the old legacy library, instead of returning an error that we could then handle and go back to the other library, it crashed and it took down the batch processing as Mark was describing. And it's an interesting problem, actually, from a unit test perspective. It's an example of what we would call a negative test, where generally speaking, when you're writing unit tests, you write unit tests to test, does the thing work the way I expect it to, versus does it not work when I give it totally unexpected data? And so there's a need, and whenever you're writing software, there's a need to say, like, yes, it works in the expected case, but also does it handle an unexpected case properly? And so there was a gap in the testing there.
And a clarifying question, Brendan, why are we talking about encryption at all at this stage? Do we have to encrypt during this process?
Sure. No, I think we do, because whenever we're doing a deployment of a resource or of a collection of resources, those resources contain information that is private to the customer. An example would be when you're deploying a virtual machine, it might include a password, or it might include other kinds of keys, other kinds of personal information that you don't want shared. And so we encrypt that data at rest as sort of a defense in depth for our customers, so that if, in security, we are taught to have an assume breach mentality. And obviously, if we assume a breach of these batch processing worker jobs, we don't want them to also be able to decrypt the data. And so we take the user data that's associated with these deployments and we encrypt it so that at rest, it's not readable by a malicious third party.
Great, that makes a lot of sense. Mark, I'll turn to you. Where I wanted to understand a bit more about the incident timeline here. When and how did we initially detect the issues? And I was looking at the post-incident review. It seems like it took about 8 hours for us to be able to correlate the issue with the specific release or the versions related to the certificate rotation. Any learnings you can talk us through about that detection or the mitigation itself?
Yeah, I think we definitely had some detection misses there, that it took us longer to figure out what was going on than we would have liked. that the biggest problem we had was we had an asymmetry in monitoring configuration between the China cloud and the public cloud, that the monitors we have for generically detecting process crashes weren't firing alerts in Mooncake or in the Azure China cloud. And so we didn't have that kind of health signal coming in telling us that our roles were crashing. And so it took a while to kind of figure out, hey, that's what's going on, that during this rotation process that when workers found a job encrypted with the wrong one, if they hit that, that was a kind of a poison job to them. And so if they hit that, they crash. And it just took a while to figure out what was going on. Once we determined that, hey, it was kind of crashes going on, we at this point we didn't know what the RCA was. We followed our standard playbook of, hey, if we see something kind of some sort of crash or something like that, roll back to the last known good. And so that's the point we decided that, hey, we are going to start a rollback in the China cloud back to a previous version of our release in case that was related to the crash, and it happened and that was the case, and so that mitigated the incident.
And Mark, can I ask a question? I'm not sure of how fitting this is. I know that during this time we're retiring V1 of Azure, classic RDFE, and I know ARM is our V2 and kind of the modern version of what we're looking for our control plane. Did this have an impact? Was this in any way related to this outage? Did it affect us at all? I
mean, good question. It did impact a little bit, just for making it a bit more confusing for our engineers on what was going on, since we're still ARM is running in the Azure China on both some instances running on the classic compute, some instances running on VMS on the virtual machine scale sets, and so having more stamps running in the China regions kind of made it a little bit more confusing for the engineers about what was going on.
Cool, neat explanation. Good to understand that. Kind of might have slowed us down a little bit in the investigation. Even once we correlated and figured out, what was happening here, it took us about 5 hours to be able to roll back to the last known good build. Brendan, is that common for us to take that long to be able to roll back?
Sure, I think it's important to distinguish between, how long it would take us to roll back if we wanted to go as fast as possible, and choices that we make around how fast we go to preserve stability in the platform. And in this particular case, we made a decision that because the impact was there and customers were feeling pain, but it wasn't a complete outage, that we would proceed relatively slowly with the rollback, because sometimes you make things worse by rolling back. And so we wanted to make sure that as we took the steps to roll back all of our instances to the older versions, the known good versions, that we weren't going to make the problem worse. And so it's fairly standard process, even as we do rollback, to follow things like safe deployment. And you're always kind of measuring, what's the cost of the current impact versus what's the risk of causing more impact as you go through that. And so in this particular case, that was the timeline that seemed to be the sweet spot between fixing problems for customers, but also minimizing risk to the platform of any kind of additional outage.
Yeah, since I think the one thing I'd add there is just that hey, now after we've done the postmortem, we know exactly what caused it. But at that point, it's like we had some theories, we knew there was crashes, and so we rolled back one stamp, verified that, hey, we're not seeing this anymore. Now we're going to keep going with kind of following that strategy broadly, that just without knowing what's going on, broadly kind of redeploying everything could easily make a problem much, much worse.
Super, and saying it quite calmly in this arena is great, but I know during the fog of war and during an outage, it's a little bit more heightened. Mark, if I could ask you a question. Beyond improvements to monitoring, in the PIR, we mentioned that we're moving our background jobs encryption to a newer technology. Can you talk about this newer technology a little bit more, or share some insights?
Sure. That the historic encryption technology that we've had requires us to manually rotate the encryption certificates, which is definitely not a modern security practice that we want to follow. That it's any manual process is more error prone. It's also a slower process because we have to do that. So we're adopting a standard encryption technology for foundational Azure services, which automatically rotates the encryption keys, and so we don't have to do any of this error-prone manual rotation once we've cut over to that. just for safety purposes, that we in the China cloud, we completed in a standalone release, we completed the legacy encryption certificate rotation, and then the next release we do to ARM in the China cloud, we'll switch over to using the newer encryption library as for any new data that we encrypt.
Yeah, and I think that's an interesting point that Mark alluded to there a little bit, which is that in this particular case, we had actually made a choice to combine both a certificate rotation with a change in the way that we were doing the primary encryption. And I think that choice of combining two changes in a single release also was part of what contributed to the fog of war in trying to figure out what happened. And so, as we go back to restoring ourselves and moving forward, in this current iteration, we've chosen to separate those out, and we're going to do a rotation in one release and then a migration in the next release, so that obviously it makes it easier to understand what changed in the system if a problem does manifest.
Great, even more cautious next time. That's good to hear.
And there's always a balance, right, between speed of wanting to get things done versus stability of the system and understandability of the system.
Great, good to tweak that balance. Brendan, last question for you here. I understand you mentioned that the code bug initially in that underlying library, that's a dependency that isn't an ARM thing, but it is a Microsoft thing. Can we encourage that team to go and add the unit tests you were talking about? How do we catch that kind of thing moving forward?
Sure, and we have strongly encouraged that team, and they have added that unit test. I think everyone who supplies, who's a central team that supplies that kind of library wants to ensure that that they have the right correctness in their testing, and that testing has been improved. And I think, but more broadly, I think we try and take those lessons and take it back and say, no, let's not just focus on testing that specific bug, but let's also remind people that negative testing is an important part of getting unit test coverage. So you can get perfect unit test coverage of all of the code, or near perfect by following the happy path. But it's a reminder that, to truly have good coverage of your tests, you have to have tested the unexpected paths too. And oftentimes that's a very small amount of code, right? So the incremental code coverage that's provided there won't show up on a dashboard, but you have to have it in your head that I need to not just test the happy paths, but test the unexpected paths also.
Cool. I'm glad that we're looking out for this kind of thing and not just this thing. That makes a lot of sense. I've saved my last question for Sammy. Sammy runs our incident communications team. And so at this point, I'd like to turn to Sammy and ask, how did we do? Did we keep customers up to date? What do we think?
Super. So when it came to comms, there's a few things. Typically, we communicate in UTC, but in China, our China cloud, we communicate in CST, and for our Gov cloud, we communicate in Eastern Standard Time is EST. But for this one, so when you see it on our status page, you'll see CST time zones instead of UTC. While impact started at 8 a.m. CST, we didn't send our first communication until about 12 o'clock, and that was for Databricks. And we were communicating to Databricks customers saying, hey, there's an issue there, and we're still trying to investigate. It was only 2 hours after that when we realized that the issue was connected to ARM. Once we thought it was an ARM issue and the ARM was down, and during the fog of war, we thought that actually the entire control plane was down versus it's just not returning the process did run successfully, but we thought it was down. We went to the status page, because if ARM is down for the entire region or the entire geography of China, nothing gets created, nothing gets deleted. And so we went to our public status page there, and we over-communicated to all customers in China North 3 and in China to say, hey, our ARM is likely going to be impacted. You won't be able to create, delete, or scale or anything like this. Of course, one of the reasons that we invest in this technology called Brain, which is the automated way to communicate to customers, to impacted customers, is because we know fog of war is tough. Understanding who is or isn't impacted is tough. Understanding which services are or are not impacted and how they're done is very difficult. And humans, as wonderful as we are, we're not great at this. And so investing in our Brain technology is really the path forward. It typically communicates to customers within 15 minutes. We had plans to onboard it. We call them semesters, which is when we kind of do loads of work. It was deferred for the other work, but it's a great reason for us to kind of expedite getting this done excuse me, in the next semester. Otherwise, we end up going to things like the status page or over-communicating by several orders of magnitude, which is nothing we really want to do. So we definitely have learnings from the comm space.
Good. Learnings for ARM, learnings for the dependency, and learnings for comms. So that's a good way to do it. Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, Incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too, and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alert set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.